Hello everyone, myself Supriya Ghadke. I hope all are safe in home. So today's lecture I am discussing the shortcut method. So from shortcut method I discuss case 4 and case 5 here. Now I can discuss this method case 3rd previously. So all of you know this method. So this case 4 is for LD, that is linear differential equation, phi of dy is equal to f of x when f of x equal to e raised to x into v. If the function, that is f of x, is of the type e raised to x into v, then we can apply the case 4. So case 4 is here that v is either polynomial or any function of sine function or cos function. So that is yp is equal to 1 upon phi of d e raised to x into v, that is equal to e raised to x into 1 upon phi of d plus a into v. That d we can replace by d plus a. Here a is the coefficient of x, that is a is the coefficient of x. So this is the yp by using case 4. I can repeat this equation again. So yp is equal to 1 upon phi of d e raised to x into v, that is equal to e raised to ax into 1 upon phi of d plus a. Here we can replace that d by d plus a into v. V is any polynomial or sine or cosine function. So take exponential function outside of operator, that is the operator, and replace d by d plus a. So here we have to replace that d by d plus a. For example, here 1 upon d square minus 4d plus 5 into e raised to 2x into sine of 2x. Here that is e raised to x into phi. Phi is any sine or cosine function. So that is the sine function. So here we can use the case 4. So that case is take outside exponential function, that is e raised to 2x, take common out here and replace that d by d plus a. So here a is 2. So replace that d by d plus 2. So here d plus 2 bracket square minus 4 times d plus 2 plus 5 into sine of 2x. So after solving this we get d square plus 4d plus 4 minus 4d minus 8 plus 5. Here expansion of this term and multiplied by 4 to hold this bracket term plus that 5 as it is, and these whole terms e raised to 2x sin 2x as it is. So after simplifying here 4d minus 4d get cancel out, 4 plus 5 that is 9, 9 minus 8 is 1. So that is d square plus 1 here, e raised to 2x as it is, 1 upon d square plus 1 as it is, and that is sine of 2x. So that is equal to e raised to 2x. So here is sine function. So if there is the sine function we have to use the case second. Case second is if the function is of the form sin x or cos x, then we have to replace the d square by minus a square. Here a is 2, so here we have to replace d square by minus a square, that is minus 4. So that is equal to that e raised to 2x as it is, 1 upon d square is replaced by minus a square is 2, so minus 4 plus 1. Minus 4 plus 1 is minus 3. So answer is e raised to 3x upon minus 3 sine of 2x. That is our pi. Here no term of d or integration term appears here. So that is our final yp. So now next example is this example we discuss now. So now next example is d square minus 4d plus 4. We have to find pi of the function d square minus 4d plus 4 into y is equal to e raised to 2x into x raised to 4. So solution of this function is, solution given d is d square minus 4d plus 4 into y is equal to e raised to 2x into x raised to 4. Phi of d is equal to d square minus 4d plus 4 and f of x is equal to e raised to 2x into x raised to 4. So here f of x is e raised to 2x into v, where v is x raised to 4. So here we have to use the case 4. So pi is equal to 1 upon phi of d into f of x. After putting the values of phi of d, f of x, our function becomes 1 upon d square minus 4d plus 4 into e raised to 2x into x raised to 4. So here replace d by a plus 2, sorry, d plus 2. Here value of a is 2 and kept exponential term outside. So our equation becomes e raised to 2x, that term outside, and replace that d by d plus 2. So d plus 2 bracket square minus 4 times d plus 2 plus 4 into that function. Function is x raised to 4. So pi is equal to e raised to 2x 1 upon d square plus 4d plus 4 minus 4d minus 8 plus 4. After simplifying this term, we get these all terms into x raised to 4 as it is. So after simplifying, 4d minus 4d cancel, 4 plus 4 is 8, 8 minus 8 is 0. So here only d square term remains. So pi is equal to e raised to 2x 1 upon d square into x raised to 4. So 1 upon d square is nothing but the double integration of this term. So first we have to take first integration e raised to 2x 1 upon d, 1 upon d as it is, 1 upon and 1 of the 1 upon d is nothing but the integration. So integration x raised to 4 dx is x raised to 5 upon 5. Again 1 upon d is here. So all of you know 1 upon d is nothing but the integration. Again we have to use here integration. So integration of x raised to 5 upon 5. This term is as it is e raised to 2x integration x raised to 5 upon 5 dx is equal to, that is e raised to 2x into integration of this term is x raised to 6 upon 6. So 6 into 5, that is 30. That is our final pi. This is the case 4th. Now we have to discuss the case 5th. So case 5th is for the linear differential equation phi of dy is equal to f of x, when f of x is x into v, where v is sin ax or cos ax, then our pi, that is 1 upon phi of d x into v, is x minus 1 upon phi of d into phi dash of d bracket close 1 upon phi of d into v, or x minus phi dash of d upon phi of d bracket complete 1 upon phi of d into v. This is the formula for finding yp. So by using this formula we have to find the yp. So there is some rule to apply this case 5. So first rule is power of x is 1, that power of this x is remains 1, and second note is 1 upon phi of d applying on v. So that term 1 upon phi of d into v, that operator operating on that v is not case of failure. Okay. So problem of that function are, so first problem is solve d square plus 4y is equal to x times sin x. Solution is auxiliary equation. To we have to solve this equation. So we have to find auxiliary equation, then we have to find CF, and then we have to calculate the PI. To calculate the CF, we have to write the auxiliary equation. So auxiliary equation is d square plus 4, that is equal to 0. So that implies d is equal to plus minus 2i. So CF is C1 cos of 2x plus C2 sin of 2x. So our pi is equal to 1 upon d square plus 4 into x times sin of x. So that is equal to, in bracket, so here we have to use the formula. So our formula is x minus phi dash of d upon phi of d bracket complete 1 upon phi of d into v. So here v is sin x. So that is equal to x minus phi of d is d square plus 4. So derivative of this term is 2d. So here is 2d upon phi of d as it is. So d square plus 4. bracket complete, 1 upon phi of d. Phi of d is d square plus 4 into sin x. So that is equal to x minus 2d upon d square plus 4. So uh, here 1 upon d square plus 4 applying on sin x. So this is the case second, because this function is sine function, and when the function is of the type sine or cos, then we have to use the case second. So we have to replace that d square by minus a square. Here value of a is 1, so we have to replace that d square by minus 1. So here is minus 1 plus 4. So minus 1 plus 4 is plus 3. So 1 by 3 take common out here, and this whole term as it is, x minus 2d upon d square plus 4 into that sin x. Now multiply this sin x in the bracket term, 1 by 3 as it is, x sin x minus 2d upon d square plus 4 into sin x. Now here again we have to apply the formula for, uh, not formula, we have to use the case second here. So again that replace d square by minus 1. So here minus 1 plus 4, minus 1 plus 4 is 3. That is x sin x as it is, 1 by 3 as it is, x sin as it is, minus 2d, that upper terms, into sin x as it is, and here we have to replace that d square by minus 1 square. So minus 1 plus 4 is 3, so that is 3, and d is nothing but the derivative of sine. So derivative of sine is cos, so that is the cos. So that is our yp. So general solution is y is equal to c1 cos of 2x plus c2 sin of 2x plus 1 by 3 times x sin x minus 2 times cos x upon 3. That is our general solution. Okay, thank you for watching the video. If you don't subscribe my channel, please subscribe this channel to watch more videos. Thank you.